Okay. In the last class, we were discussing, we have started from the carbon monoxide, and then methane, then we have discussed NOx, then we have discussed SOx, like sulfur oxides and nitrogen oxides. Okay. And then I told you that nitrogen dioxide can be released from the car engines, and basically they contribute to acid rain, right? um, Basically effect of NO2 is to produce acid rain that is very dangerous for the environment. And I told you the adverse effect of acid rain basically. Okay. So in today's class we would be discussing in detail, okay, how the acid rain is going to be produced. Remember, acid rain is produced by the reaction of NO2 with water and by the reaction of SO2 with water. There are two factors. You can say that there are two sources of acid rain. The first is from NOx, like NO2, and then from SO2. NO2 can also produce acid rain, and sulfur dioxide can also produce acid rain. Okay. So uh, let's suppose this is the sulfur dioxide that is released from the chimney, okay, from the power stations, from the volcanoes, and I told you in that day, and it's going to react with O2, then it's going to react with water. You can say in the presence of water, it would be producing H2SO4. This is your balanced chemical equation, right? This equation says that when sulfur dioxide is released, okay, is released from the fossil fuel, the combustion of the fossil fuel. So obviously nitrogen sulfur dioxide is a gas, so it releases to the atmosphere. Okay. In atmosphere we have the water droplets. I told you in the last class, in the form of moisture, which basically moisture is the water droplets. Okay. You can say when rain started, okay, so we can see the water droplets, and that water droplets are going to mix with, you can say, this sulfur dioxide and they would be producing sulfuric acid, right? And you all know that sulfur dioxide, you know that sulfur is a non-metal. Sulfur is a non-metal. When you see oxygen that is combined with non-metal, I'm repeating, whenever you see oxygen that is combined with any non-metal, so they would be producing acidic oxide. You're supposed to note this point. I'm telling you that when oxygen is going to attach with any non-metal, in this case it may be sulfur, it may be nitrogen. In both cases, nitrogen, whether you have sulfur, when they are going to mix with oxygen, so they would be producing acidic oxide. Remember. And when acidic oxide is going to dissolve in water, so they would be producing the acidic solution. That's why we are saying that this is an acid rain. Let's suppose if I ask, Amaya, can you tell me carbon dioxide, is this acidic or not? Yes, Amaya, what do you think? Amaya, can you hear me? And also Fatima, also Maheen. Yes,
Yes, it is acidic.
it
It
is
is
acidic.
acidic.
Why? Why this is acidic? Why this is acidic? Can you explain? Amaya, yes, can you explain it? Why this is an acidic? Amaya, you are muted. Adan, what do you think? Aryan, what do you think? Reni, what do you think? Is this acidic or no? Yes. Oh my God, you are all silent
Yes,
today.
Mr. It's acidic.
Why? Why
Um,
this is acidic? Why?
When it's dissolved in water.
This is a non-metal. Carbon is a non-metal. That's why this is acidic. Okay.
yes.
Carbon is a non-metal, yes. So that's why this is a this is acidic oxide. When oxygen is combined with any metal, it may be sodium, it may be magnesium, it may be potassium, it may be lithium, it may be cesium. So that would be basic oxide, basic oxide. But right now, I don't want to discuss this. We would be discussing in acid, base, and salt. Basically, this is an acidic oxide. When it's going to react with water, it's going to mix with water. So they would be producing acidic solution that we call acid rain. Okay. So that's why this is the source of, you can say that acid rain. So remember, in this case, I told you that it's going to produce sulfuric acid and it's going to produce nitric and nitrous acid. Remember, NO2 can produce nitric acid, it can produce nitrous acid. In both cases, they both compounds would be reacting with H2O, would be reacting, like you can say, you would be mixing with H2O and they would be producing acidic solution. They would be producing acidic solution in the form of acid rain, in the form of acid rain. Remember, they are aqueous, they are aqueous, they are aqueous. What does it mean? What does it mean? Aqueous means this is soluble in water. So when water droplets, when they see the water droplets, when they see, when they see water droplets, so they just got mixed with the water droplets, and the water droplets come to the, you can say, the surface of the earth. So basically, they would be, you can say, the soil would be getting too much acidic. You know, I told you in the adverse effect of acid rain, the soil would become acidic. And you know, we can't plant any tree because the soil should be, you can say, neutral so that we can plant a tree. So then I told you how we are supposed to uh, eliminate the acidity of the soil. Okay, then I told you that you are supposed to add calcium carbonate, okay, limestone, so that your salt may be neutralized with this base, and then we can plant a tree. So by the way, uh, this is the way that we can, you can say, produce acid rain. And remember, and remember, uh, during lightning, during the rain, during the rain, basically there is a lightning, there is a lightning. You know, I told you in the last class that nitrogen is inert. Nitrogen is inert gas. Inert means unreactive. Inert means unreactive. So Adan, can you tell me why nitrogen is inert, why nitrogen is unreactive? Yes. Yes. Can anyone tell me why nitrogen is inert? Why nitrogen is unreactive? Yes, what's the reason that I told you in the last class? Mm-hmm. Yes, Huria, Hamna.
Sir, it has a triple bond.
So it has a
Uh,
triple
Oh,
bond.
nice.
yeah, it has a
Nice.
triple
Yes,
bond
it
with the
has a
base
trip bond.
bond.
Exactly. So it requires a lot. But remember, when there is a lightning, when there is a lightning during the rain, when there is a lightning, so lightning is going to provide so much energy to this nitrogen gas. So, you know, in the presence of lightning, the nitrogen would be breaking down. Remember, this is very important. Nitrogen, which is having triple covalent bond. So when the lightning strikes on this nitrogen molecule, So the nitrogen would be breaking down, and it would be reacting with this oxygen gas to produce NO2. And when NO2 mixes with water, they would be producing HNO3. So that's why this is also an acid rain. I'm not responsible. You are not responsible. This is natural. This is natural. So when there is a lightning, obviously nitrogen, which is in the atmosphere, which is in the air, 78% nitrogen is there and 21% oxygen. But fortunately, they are not going to react with anyone, you can say with each other, because nitrogen is inert. At normal condition, normal temperature, normal pressure, nitrogen won't react with oxygen because it has triple bond. It's so much unreactive, it's so much inert. It's not supposed to react with oxygen gas, right? But when there is a lightning, so nitrogen would be reacting with oxygen, okay? So it would be producing NO2. And obviously I told you that when NO2, see this equation, when NO2 mixes with H2O and oxygen, obviously oxygen in the atmosphere, in the air, so they would be producing HNO3. This is a nitric acid. So we would be having this nitric acid in the form of rain, basically, okay? Yes. You can say that if I go deeper, so I can say that, when the cloud rises, listen very carefully. When the cloud rises, okay, let's suppose, let's suppose, oh my God, where is the picture? So if you can see, when the cloud rises, okay, so remember the temperature decreases. As you are going upward, the temperature is going to decrease. When the temperature decreases, so the droplets get larger. So the droplet gets bigger and bigger and bigger. So when these water droplets containing acids, acids particles, it may be sulfuric acid, it may be nitric acid. So it becomes heavier. So they fall down. They just fall down as acid rain. Okay. So this is all about acid rain. And then afterwards, we have, like CFC. I told you this is chlorofluorocarbon. This is also the responsible for the pollution because they are going to, you can say, deplete ozone. Basically, CFC depletes ozone layer. How the CFC depletes ozone layer? So remember, when UV light strikes, into this compound, into this molecule, so you can say that the bond between carbon and chlorine will be breaking down. Okay, the bond between carbon and chlorine will be breaking down, right? Okay. Okay, the bond between carbon and chlorine will be breaking down. Why not the bond of carbon and fluorine won't be breaking down? Why? What's the reason? I told you in the last class that the size of fluorine is so much smaller, so the bond is quite stronger. Okay, so that's why this bond is not going to be broken down, but the bond between carbon and chlorine would be breaking down and they would be producing chlorine. This is a radical. This is a free radical. Okay, what is radical? Basically, radical contains unpaired electrons. You can say odd number of electrons. So when something is having odd number of electrons, they are quite unstable, highly reactive. So when this chlorine radical is going to react with this ozone, so it would be breaking down the ozone into oxygen gas. So obviously your ozone has been broken down. Your ozone layer has been depleted. So this is what the CFC does. Okay. So in short, I can say that your ozone is completely converted into the oxygen gas. But remember, this is completely banned in all over the world because this is responsible to deplete the ozone layer. So it is substituted by HFC, hydro. Okay. So basically, we have eliminated chlorine. Basically, we have eliminated what? What chlorine, basically. Okay. So now the thing is that ozone, you can say that ozone is, uh, you can say, in upper atmosphere, it's a good thing. It's a good thing. Okay. Because it protects us from the UV radiation. It protects us from the UV radiation. But when it comes to the lower atmosphere, this is so much harmful. This is so much harmful. Remember, okay, this is so much harmful basically. So when nitrogen dioxide is going to react with oxygen, so it produces O3. It produces O3, that is ozone. It's so much harmful when it's in the lower atmosphere, but it's a good when it's in upper atmosphere because it protects us from the UV radiation. Okay. Then we have, I told you in the last class when we were discussing most of the pollutants, then I was telling you again and again the solution is catalytic converter, the solution is catalytic converter. So today we would be discussing how the catalytic converter works. So this is the simple ray diagram of the catalytic converter. So as you can see how it looks like. Basically, catalytic converter are fitted to the motor vehicles to convert unburned hydrocarbons and other harmful gases into harmless compounds. In short, I can summarize it. In short, I can say that if you have CO that is most dangerous, colorless, odorless, very toxic gas enters from here, and let's suppose when it goes like in the form of CO2, okay, when it exits from here, so it would be CO2 rather than CO. How the CO is converted into CO2? This is the main question. How the carbon monoxide is converted into the carbon dioxide? In this converter, interestingly, in this converter, we have a very precious metal that is platinum and palladium, rhodium. Platinum and rhodium, basically. It can act as a catalyst. It can act as a catalyst. So let's suppose this catalytic converter is fitted with this vehicle, okay. This is the, okay, with this vehicle. So when this vehicle emits a lot of harmful gases, including this, including this, including this. So when they all enter from this side, okay, when they all enter from this side, so this is the catalyst, okay. This is, you can say, the honeycomb, just like a honeycomb, basically, and coated with the catalyst such as platinum and rhodium. So this oxide is converted into this oxide, okay. This oxide is converted into this, right? And this is converted into this water vapor. Water vapor. This is very important to know. This is very important to know, right? This is very important to know. So in short, oxides of nitrogen reacts with oxides of carbon in the presence of platinum and rhodium catalyst. They produce CO2 and they produce N2. You know, I know that I told you in the last class that carbon dioxide is also a pollutant. Like it can produce the global, it's a greenhouse gas basically, right? But if we are going to have a comparison between monoxide and dioxide, so monoxide is too much dangerous and carbon dioxide is not too much, okay? So how the catalytic converter works, how the catalytic converter works. So you must know this equation, right? Okay. And we have unburnt hydrocarbons. Like if you are going to use a bad fuel, like you can say unofficial fuel, which is not, you can say, refined carefully. Okay, so when you are going to use that fuel, so some particles would be you can say unburnt. So so those unburnt hydrocarbons can also be oxidized into the CO2 and water. So who is doing this? Who is responsible for those all? You can say the catalytic converter. We are going to have some topical past papers, don't worry about that. And then I told you that this is a flue gas desulfurization. So what this method tells basically, I was telling you when we were discussing sulfur dioxide, then I told you that how can we eliminate? I was telling you that we must know the source of the pollutant, the effect of the pollutant, the solution of the pollutant. Let's suppose for this sulfur dioxide, that is a pollutant, the source is the combustion of fossil fuel, the effect is the acid rain, and the solution is the flue gas desulfurization. This is the method by which we can remove SO2 and NO from the waste gases from the power station. Let's suppose this is a power station from which the sulfur dioxide and nitrogen dioxide is released to the atmosphere, to the environment. Okay, to the environment. So how we are going to deal with these gases? Through flue gas desulfurization. Desulfurize, desulfurize, removal, degrade. Like we are going to decrease the grade, we are going to decrease, we are going to eliminate such sulfur, like the sulfur dioxide. So now step number one, calcium carbonate is added to the hot, okay, to the hot gas, to the hot flue gases. In the presence of heat, they decompose. Who is going to be decomposed? The calcium carbonate. When the calcium carbonate is decomposed into the calcium oxide and carbon dioxide, as I told you, this is calcium oxide. Calcium is a metal. I told you yum. Sodium, lithium, potassium, rubidium, cesium, francium, aluminium. They are metals. So their oxides are basic. Their oxides are basic. Their oxides are basic. So this is a basic oxide. And what about sulfur dioxide? This is an acidic oxide. Why? Because sulfur is a non-metal. Oh, so they would be reacting together. This is an acid-base reaction. They would be producing calcium, okay, sulfide. So this is how the calcium oxide is going to react with this sulfur dioxide to produce CaSO3, and how the CaSO3 is further going to react with oxygen to form calcium sulfate. This is wow. This is why the sulfur dioxide is removed from this, okay. So when the examiner would ask how we are supposed to remove sulfur dioxide from these gases, waste gases, so you will say that we are supposed to add calcium carbonate first. Obviously calcium carbonate, obviously there is a very high temperature, so you don't need to do anything else. But when you would be introducing calcium carbonate, it would be breaking down into calcium oxide and carbon dioxide. I don't need this dioxide, I need this calcium oxide. Okay, because this is a basic nature, this is having a basic nature. It would be reacting with the sulfur dioxide, that this is an acidic gas, and that would be producing calcium sulfide. Okay, in this way, and this is a solid, so you can just remove it, solid can be removed easily as compared to the gases, okay. So this is what this gas, the flue gas desulfurization, this is what the flue gas desulfurization. Okay, I'm hiding this, and I'm going to ask Mohaimin. Mohaimin, can you tell me this? Mohaimin, can you tell me how we can remove sulfur dioxide through the flue gas desulfurization? Yes, Mohaimin, can you tell me, please? Yes. First. No, you're not going to tell me. Hmm? And also Ayat Zubair. Can you tell me this? No? Yes, Amaya. Can you tell me this, Amaya? I told you just now, man. Yes. I'm expecting the answer, right? Maheen, can you tell me this, Maheen? Maheen, what I told you regarding flue gas desulfurization, I want to check that you are with me or not. I'm waiting for all of you, right? Maheen, yes, you're saying
You
something else.
decompose calcium carbonate.
And then afterwards, what happened? Yes, Abdul Wase. Adan.
Yes, sir. We decompose calcium carbonate. It changes to calcium, carbon dioxide and
Calcium
calcium
oxide.
oxide.
Oxide, yes. Then, and then what happened? Mm-hmm. Mm-hmm.
Yes,
Mm-hmm.
really.
Yes, Ayat Zubair. Yes. Then what happened basically? Yes. Mm-hmm. No? Oh my God, you are sleeping all. Oh. I told you calcium oxide would be produced. Calcium oxide is a basic oxide. It would be reacting with sulfur dioxide. That this is an acidic oxide, and they would be producing a salt. That is solid, so we can remove this salt very easily. That's it. That's called the desulfurization. So the sulfur dioxide is moved in the form of this, in the form of this, in the form of this, in the form of this. That's it. Are you all getting my point? Should I
Can you
go
explain
ahead?
it slowly once more?
Okay. I'm telling you that I want to remove SO2 from here. Okay, SO2 from here. So what I do basically, see this, see this, see this, see this, see this, see this, see this. I have added calcium carbonate over here, right? Okay. Then calcium carbonate produced calcium oxide because it has been decomposed. It's decomposed at a higher temperature. Okay, then this is finished. Now we have this. Now we have this calcium oxide. Now we have this calcium oxide, right? Now we have this calcium oxide. So now how the calcium oxide is going to react with this sulfur dioxide? So CaO would be reacting with SO2 to produce this. This is a solid. You will see a solid deposition over here. A solid deposition over here. Just remove it. Just remove it. So this is how we are going to we are going to remove the sulfur dioxide. Basically, we have converted this gas into the solid, and the solid is calcium sulfide. And how the calcium sulfide, I mean to say CaSO3 is produced by the reaction of CaO with SO2. So from where the CaO came, you will say the decomposition of calcium carbonate. That's it. Are you getting my point, Fatma? Did you understand this?
Yes.
Yes or no? Okay, good. Everyone, yes. Should I go ahead? Did you get all the points?
Yes.
Yes or no?
Yes, sir.
I need 10, 11
Yes, sir.
answers. Okay, 3 answers. Yes. And then,
Yes.
Yes.
okay, bhai, okay,
Yes,
okay,
sir.
bhai. Okay, good. Good boy. Then we have a greenhouse effect. Warming of Earth surface with heat from sun trapped in the atmosphere by greenhouse. You know, greenhouse is a good thing for us. Interestingly, fortunately, if there are no greenhouse gases, so we would all die by the coldness, you know. Let's suppose if there are no any greenhouse gases in the atmosphere, so the temperature of the earth is too much lower. That is like we can't live. We can't live. So basically, this is natural that we have a greenhouse gases, CH4 and CO2, then N2O. These all are greenhouse gases. What they do basically, what they do, let's suppose sunlight is releasing, you can say the sun is releasing so much energy, okay? When this energy come to the surface, okay, when this energy come to the surface of the earth, and they just bounced back, reflected, they just reflected, energy released back into the space, okay? This is the natural phenomena, this is the natural phenomena basically. So but we have some gases, they that are not allowing, the this energy back to the space. Basically they trapped the energy, and that energy is enough for us to live in this atmosphere. They balance the temperature of the environment. They balance the temperature of the environment. I mean to say that. But when you have excess of these gases, when you have excess of these gases, okay, when you have excess of these gases, remember, when you have excess of these gases, so they are quite harmful for us. They would be increasing the temperature to some extent. To some extent, let's suppose I was telling you in the last class that the temperature of the whole world is going to increase by 1 degree Celsius. Okay, so last time the temperature of the maximum temperature was 52 degrees Celsius. So the coming year the temperature would be 53. Average increase in temperature is 1 degree Celsius. This is quite alarming. This is quite alarming situation for us, right? It's due to the greenhouse gases. We are going to release so much greenhouse gases into the atmosphere in the form of CH4, in the form of carbon dioxide, in the form of, and why we say that just plant a tree, just plant tree, just plant trees. Why? What's the reason? Basically, by planting a tree, they would be absorbing carbon dioxide. So you can just decrease the amount of carbon dioxide from the environment to some extent. Yes, we can decrease, we can control, but we cannot eliminate completely. Like we can say that 100% we have eliminated all the greenhouse gases. No, that's not possible. We can control it, right? So basically what the greenhouse gases do, they are beneficial, that maintains the temperature of earth and support the life on earth. But excessive amount of these gases, let's suppose undesirable warming of earth, that we can't live, undesirable warming of earth due to trapping of excessive heat from the sun in atmosphere by the greenhouse gases, that's called global warming. When excess amount of CO2 and CH4 are introduced into the atmosphere, they trap heat and they give rise to overheating. So what are the effects? The effects are extensive floods, melting of ice, increase in global temperature, that I was telling you, that increase in temperature, average temperature is 1 degree Celsius by each year. So these are the adverse effects of the global warming, that we would be facing a lot of floods, okay, due to the melting of the glaciers and increase in the global temperature. So that's all about the air. I told you that there are two parts of this chapter, air and then water. So we would be discussing water, right? But we are supposed to do some topical papers related to this. So let me open some topical papers that we can do to enhance and to excel our concepts. Just wait. Tell me this. Can you tell me question 25? Yes?
C.
C. Okay. Oxides of nitrogen and sulfur dioxide. Yes. Right? Yes, anyone? Can you confirm, please? Yes, anyone?
I also think it's C.
Good. Exactly. This is C. Why? Because I told you NO2 is going to produce HNO3, that is nitric acid, and SO2 is going to produce H2SO4, that is sulfuric acid. Then they both are responsible for the acid rain. They both are responsible for the acid rain, right? Number 30. Can you tell me question number 30 that just we did right now? This is a good question. Now I am going to check your IQ level. Just we did this question. Can
Is
anyone
it
tell me this?
B?
Yes.
B.
B for ball or D? This is B for ball. Exactly. We did this equation just right now. We did this equation. Monoxide is going to react with monoxide. Okay. NO and CO, they are going to react together in the form of, like in the catalytic converter, and they are going to produce nitrogen gas and carbon dioxide. So basically the catalytic converter has converted this oxide, the monoxide, into the dioxide, more harmful to the less harmful, and nitrogen oxide into the nitrogen gas. Again, the more harmful into the less harmful. That's it. Good. Good. Yes. Question number 32. Yes. Question number 32. Yes. 32. Yes. Yes.
C.
C. Hamna is saying C. Huria, Fatma, Aryan, Amaya, Adan, Abdul
B.
Base, Maheen, Mohaimin.
It's
What do
C.
you think?
It is
C.
B.
B.
B or C? B for ball. Okay, some are saying B and some are saying C. So what is the correct answer? They are saying the gases from the engine of a car. The gases from the engine of a car contain oxides of nitrogen, like NO, like NO and NO2. Okay. How are these oxides formed? How are these oxides formed? So basically, nitrogen is going to react with oxygen. Nitrogen is going to react with oxygen, right? Nitrogen is going to react with oxygen basically. So they are going to produce NO and NO2. Okay, NO and NO2. So the C is your answer. C is your answer. Okay. Now see another question. Okay, 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 okay. Okay, 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 okay. Hmm. Yes, see this. 32. Question 32. Question 32. 32. Yes. Fast. 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 Fast, fast, fast. Yes, yes, yes. Which information about carbon dioxide and methane is correct? Formed when vegetation decomposes? Okay. Okay. Greenhouse gas? Okay. Uh-huh. Present in unpolluted air? Okay. Produced during respiration? Oh my God, methane is not produced. D for doctor is completely incorrect. Obviously. Obviously. Yes, can anyone? Yes, can anyone answer?
B.
B.
B
B
for
for ball.
ball. Exactly. B for ball is your complete. Okay, good, good हो गया, good हो गया, good हो गया. Good है, good है, good है. Good हो गया, good हो गया. Can you tell me the 32? Yes, 32. Hope maybe this would be quite tricky for you because hydrocarbon combustion means the burning of hydrocarbon. Burning always produce CO2 and water. So they are asking methane, that is CH4. A for apple is completely incorrect. Let me
B.
check the B.
B for ball.
Exactly.
B.
B for ball is correct because the vegetation is going to produce methane gas. I have also mentioned in my notes, I would be telling you, respiration doesn't promote, man. How is this possible? This is nonsense option. And D says reaction between hydrochloric acid and, oh my god, no. Calcium carbonate is going to react with HCl. They would be producing calcium chloride, carbon dioxide, and water. There is no any methane gas in this reaction. Okay. Uh-huh. 29. This is a good question. 29. Nice. Nice question. 29. Yes.
A.
Carbon dioxide and methane are both greenhouse gases. I know. Oh, I know. You know, yes. Which activity produces both of these gases? Farming animals, cracking alkanes, the thermal decomposition of limestone, blah, 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 using petrol-powered cars. So what you are saying? What's the option?
A.
A for apple. Okay.
Yes.
Yes. Can anyone confirm, Maheen? Maheen, you're so silent today. Why? Mohimin and Rennie. Rennie, can you tell me this? Yes, Rennie? Mm-hmm. Rennie, can you hear me? Can you hear me, Iman? Yes? Hello, Rennie. Okay, Aryan, what do you think? What's an answer, Aryan? Hopefully, Aryan would tell me. Oh, Rennie, yes, sir. Oh, Rennie has replied. Okay. Yes, sir, I'm sending the answer on message. Why? Okay, that's also okay for me. I think it's C. Okay. Aryan, tell me. Mm-hmm. Remember, C option is completely incorrect because the thermal decomposition of limestone. Limestone is, Rennie is saying C. C is completely incorrect. C is completely incorrect because C
Hello.
says yes. Hello, yes.
Yeah.
Aryan.
A.
A. Yes, okay. The thermal decomposition of limestone says that the calcium carbonate decomposes to form calcium oxide and carbon dioxide. Where is methane? Where is methane? And cracking alkane, they produce carbon dioxide and water. Where is methane? B and C option completely incorrect. Okay. And so A is option. A is the correct option. A is the correct option, right? Okay. So you are supposed to do the past papers. Okay.